It was just another day. Your app is running smoothly, customers are happy, and everything seems perfect. But behind the scenes, a silent threat lurks. Without your knowledge, a hacker has found a weak spot in your API, exploiting a vulnerability you never saw coming. In just a few seconds, your application is compromised. Data is stolen, your reputation is at stake, and the trust you have built with your users starts to crumble. Welcome to the world of API security. Whether you are building a small app or a large-scale platform, protecting your APIs from these invisible threats, it's not just nice to have, it's absolutely critical. In today's video, we will be walking you through 11 essential steps to secure your APIs against the most common and dangerous attacks. API security is not just a technical challenge, it's a battle between you and those who would exploit any vulnerability for their gain. A single oversight can lead to devastating consequences, from data breaches to financial losses, and even damage to your company's reputation. Think about it. An unprotected API is like leaving your front door wide open in a rough neighborhood. Anyone can walk in, take what they want, and leave you to pick up the pieces. But here's the good news. Securing your APIs doesn't have to be a daunting task. With the right strategies in place, you can safeguard your applications from these threats. Today, we will explore 11 simple yet powerful steps you can take to protect your APIs. We will cover everything from using HTTPS to defending against SQL injections to implementing anti-forgery tokens and more. Let's get started. Using HTTPS. Let's begin with the most basic yet often overlooked aspect of API security. Picture this. You are sending sensitive information like payment details over an API using plain HTTP. This is like sending a letter without sealing the envelope. A man-in-the-middle attack can occur, where someone intercepts and alters your communication without you even knowing. Your user's data is at risk, and so is your entire system. After using HTTPS, now your communication is safe from prying eyes. And in the cloud environment, services like AWS API Gateway or Azure API Management can handle SSL/TLS for you, making it even easier. The next one is authentication. Authentication is your first line of defense. Imagine leaving your house unlocked, anyone can walk in. Similarly, if your API is not properly authenticated, anyone can access it, leading to unauthorized data access. Think about this. An API endpoint is accessed without verifying who the user is. This opens the door to data breaches and unauthorized actions within your application. Insecure code allows anyone to access sensitive data, but we can easily secure it using JWT tokens. JWT tokens helps ensure that only authenticated users can access your API. In cloud platforms like AWS or Azure, you can use services like Cognito or Azure AD B2C to handle authentication seamlessly. The next step to secure your API is authorization, ensuring proper access control. While authentication verifies who the user is, authorization determines what they can do. Without proper authorization, even authenticated users might gain access to resources they are not supposed to. Imagine a regular user accessing admin-only functions because you haven't implemented role-based authorization. This could lead to unauthorized actions within your application. Let's secure this by implementing role-based authorization. Now, only users with the admin role can access this endpoint. In cloud environments, you can also implement role-based access control, which is RBAC, using services like AWS IAM or Azure RBAC. The next one is anti-forgery vulnerability, protecting against cross-site request forgery, CSRF. Let's talk about cross-site request forgery or CSRF. This attack tricks a user into unknowingly submitting a malicious request to your API. typically by exploiting their authenticated session. Imagine a user is logged into your web app. They visit a malicious site that secretly submits a form on their behalf, transferring money or changing account settings without their consent. This form could be submitted from another site, and if the user is already logged in, the API might accept it without verifying the origin. To secure this, we use anti-forgery tokens. Anti-forgery tokens ensure that requests to your server originate from your own application. In cloud environments, you can enhance security with session management services like AWS Cognito or Azure AD to reduce CSRF risk. The next step is validate input, defend against SQL injection and XSS. Another common vulnerability is failing to validate input. This opens doors to SQL injection and cross-site scripting attacks. An attacker could inject malicious SQL queries or scripts into your application, compromising your database or hijacking the user experience. Imagine an attacker sends a SQL query through an input field, tricking your database into returning unauthorized data. With this code, an attacker can easily inject SQL commands. Let's fix it with parameterized queries. In a cross-site scripting attack, an attacker injects malicious scripts that gets executed on the user's browser, stealing their session or redirecting them to a malicious website. This code directly renders users' input without sanitization. Instead, we should encode it to prevent XSS. Proper input validation and encoding can protect you from these threats. And if you are using cloud databases, services like AWS RDS or Azure SQL Database come with built-in protections against SQL injection. Next step is rate limiting, preventing DDoS attacks. Imagine your API is suddenly hit with a flood of requests, overwhelming your server and bringing your application to a halt. This is what happens in a distributed denial of service (DDoS) attack. An attacker can send thousands of requests in a short period, crashing your API and making it unavailable to legitimate users. To mitigate this, implement rate limiting to control the number of requests a client can make. Rate limiting protects your API from being overwhelmed by traffic. In cloud platforms, services like AWS API Gateway or Azure APIM can automatically handle rate limiting and protect your application from DDoS attacks. The next one in the list is secure data in transit and at rest, protecting sensitive information. Data is vulnerable when it's being transmitted over the network and when it is stored in your database. Without encryption, sensitive information like personal data or payment details can be intercepted and stolen. An attacker intercepts unencrypted traffic and steals sensitive information during transmission. Always encrypt sensitive data both in transit and at rest to protect it from unauthorized access. In cloud environments, services like AWS KMS or Key Management System or Azure Key Vault can help you manage encryption keys and protect your data both in transit and at rest. Next is API Gateway, adding an extra layer of protection. An API gateway acts as a front door to your APIs, providing an extra layer of security by managing and controlling traffic. It can help with authentication, rate limiting, and even logging. Without an API gateway, attackers can directly target your APIs, bypassing important security measures. Using an API gateway adds a level of indirection, making it harder for attackers to reach your backend services directly. In cloud platforms, services like AWS API Gateway or Azure APIM offer built-in security features that can protect your APIs from a wide range of attacks. Next step is logging and monitoring, staying ahead of the threats. Finally, security doesn't stop at the implementation. You need to continuously log and monitor your APIs to detect and respond to threats in real time. Without monitoring, you are flying blind. An attack could be happening right now and you wouldn't even know it. And without proper logging, you miss the warning signs. In cloud environments, services like AWS CloudWatch or Azure Monitor provide powerful tools for logging and monitoring your APIs, helping you stay ahead of the potential threats. Securing your APIs is not just about ticking off a checklist. It's about creating a robust, resilient system that can stand up to the threats of modern world. From using HTTPS, to preventing SQL injections, implementing rate limiting, and leveraging cloud-based solutions, each step you take adds another level of protection. By following these steps, you will be well on your way to securing your APIs against even the most determined attackers. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell for more tips on securing your applications. Stay secure and thanks for watching.